Now let's work some impulse momentum problems using the definition and the impulse momentum theorem. Remember the definition of impulse, we're going to use an I, even though a lot of books use J, is equal to force applied times the time period that is applied, the force is applied. The units we're going to use are Newton seconds. The newtons come from the force, the seconds come from the time. Now momentum, we use the symbol P. I know it's a little strange, but momentum is P, and that equals the mass of an object times its velocity. The units we're going to use for momentum are kilograms from the mass times meters per second from the velocity. Now, the impulse momentum theorem is very straightforward. It says the impulse is equal to the change in momentum. Now, the change in momentum is equal to the mass times V final minus V initial, or we may even write this as M delta V. Now I'm going to take the definition of impulse and apply it down here. So this is Ft. Now you can use any form of this equation you need, depending upon your problem. Let's look at this problem right here. Suppose I have a girl who has a mass of 35.6 kilograms, and she's on a skateboard of 1.3 kilograms. I want to know their momentum if they're both traveling at 9.5 meters per second. Well, let's list off our givens. The girl has a mass of 35.6 kilograms. The board has a mass of 1.3 kilograms. And they're both traveling at a velocity of 9.5 meters per second. I want to know, my unknown is momentum, so P is what? I don't know. My equation, let's go to the definition. P equals mv. Now this has got to be the total mass. So this is going to be 35.6 kilograms plus 1.3 kilograms times my velocity of 9.50 meters per second. My total mass, and I could have done this somewhere else earlier, is 36.9 kilograms times 9.5 meters per second, so that I get a total momentum of 350.55 kilograms meters per second. And go ahead and box your answer. Now, suppose I have a hockey player who's making a slap shot. He's exerting a force, F, of 30 newtons on a puck for a time, T, of 0.16 seconds. What's the impulse? Well, let's see. Givens, I have a force of 30 newtons and a time of 0.16 seconds. What am I looking for? I'm looking for the impulse. What equation am I going to use? Well, let's go to the definition. Impulse is Ft. So this is a straight plug-in. My solved solution is 30 newtons times 0.16 seconds, or 4.8 newton seconds. Now remember, when I grade this, the givens would be 2 points, one for the numbers and one for getting all the units correct, one for the unknown, one for the equation, one for plugging in, one for the answer, and one for the units. So this problem would be 2, 3, 4, 5, 6, 7 points. So just giving me 4.8 would get you 1 out of 7 points. Now let's continue on with part B of this one. We have the same situation. We want to know what would be its change in velocity if we had a mass of 0.5 kilograms. So let's see, my givens, now I know the mass is 0.5 kilograms. And I have the impulse from before is 4.8 newton seconds. I'm looking for, my unknown is change in velocity. The equation I'm going to use is impulse is equal to change in momentum, which is m delta v. Now, I'm going to switch colors here to show you how I solve this. I want delta v, so I'm going to divide through by m. This is my solve. So delta v is impulse divided by mass. So this is impulse, which is 4.8 Newton seconds, divided by the mass, which is 0.5 kilograms. So 4.8 divided by 0.5 is equal to 9.6 meters per second. So the hockey puck goes from 0, I assume it's still when he hits it, to 9.6 meters per second. Now, I have a force of 6 newtons, so there's my F, acting on a 3 kilogram object, there's my mass, for 10 seconds, there's my time. What's my change in momentum? Well, I know the change in momentum has to equal impulse, and impulse is Ft. Remember I told you, use whatever formula you can use. That makes your problem easier. The force is 6 newtons. The time is 10 seconds. So my change in momentum is going to be 60. Now I'm doing momentum, so I need the units to be kilograms meters per second. I will be looking very, very carefully at the units here. You're definitely going to get a point for those units, a point for the number, a point for solving. Now you're going to get a point or two for this right here, probably just one more. The key thing I'm going to be looking for in this is, do you have the correct units to go with change in momentum? Okay, now let's find the change in velocity. I have the change in momentum is 60 kilograms meters per second. And I know the change in momentum is m delta v. So solving this for delta v, switch colors here. I'm going to divide both sides through by m. So I have delta v is equal to the change in momentum divided by the mass. Well, the change in momentum is 60 kilograms meters per second, and the mass is 3. I should have written out my givens. So I get 20 meters per second. Now, suppose I have a baseball with a mass of 0.14 kilograms. There's my mass. And it's thrown by a pitcher with a velocity of 35 meters per second. There's my velocity. What's the momentum? P equals mv. Straightforward. We're going to apply the definition of momentum. The mass is 0.14 kilograms. The velocity is 35 meters per second. Now you would have written this all out in guess format. I just don't have room. So this is 4.9 kilograms meters per second. So I have a baseball with a mass of 0.14 kilograms. That's moving with a velocity of 35 meters per second, and it has its momentum. Now let's look at the second problem. Now we have a bowling ball of mass 7.26 kilograms. We want it to have the same momentum as the baseball. What would its velocity need to be? So we know the momentum that we want is 4.9 kilograms meters per second, and we know the mass that we have for the bowling ball is 7.26 kilograms. What does its velocity need to be? Well, P equals mv. I'm going to come over here and divide both sides through by m to get rid of it, so I have v by itself. So the velocity is going to be the momentum I want divided by its mass. And you see, as I increase the mass, my velocity's got to go down. So I have 4.9 kilograms meters per second divided by 7.26 kilograms gives me a speed of 0.675 meters per second. So a bowling ball and a baseball can have the same momentum, but the baseball is going to be traveling much, much faster than the bowling ball. Now, suppose I have a baseball of mass 0.41 kilograms. So here's my mass. It's thrown by a pitcher with an initial velocity of 38 meters per second, and it's hit back with a final velocity of negative 38 meters per second. Let's write out our givens. The mass is 0.14 kilograms. V naught is 38 meters per second. And V final is negative 38 meters per second. Okay, what does this look like? I've got the ball and it's going this way, and then it bounces back. Now, what's the impulse? Now, I know impulse equals change in momentum. So I have velocities and masses, so let me do it this way. Impulse is equal to, oh, it's not working very well, is equal to change in momentum, which is m v final minus v initial. So it's going to be the mass, which is 0.14 kilograms, times v final. Now v final is negative 38, minus v initial. V initial is positive 38. Oh my goodness, look at that. So this is going to be 0.14 times. Now look at this. We're going to have a negative sign because what we have is 38, negative 38 minus 38, or minus 76 meters per second. So the ball has a change in velocity of 76 meters per second to the left. And this is going to give me a negative 10.64 Newton seconds. Now remember, make sure you check your units on these because I'm going to be very picky. I'm looking for Newton seconds because I'm asking for impulse. Now, suppose my bat stays in contact with the ball for a time of 0.1 seconds. What's the force? Now I'm going to go to the definition of impulse. Impulse is equal to Ft. So the force is going to be the impulse divided by the time. Let's see, the impulse is negative 10.6 Newton seconds, and that's divided by the time, which is 0.1 seconds, or negative 106.4 newtons. The negative sign tells me direction, and this tells me the force. Now, what's the acceleration of the ball? Oh goodness, that's not this unit, but it is. Everything we've done before counts. We know F equals ma. So, I'm going to solve this for acceleration by dividing both sides through by m. And I have the acceleration of my ball is the force applied divided by the mass of the ball. So let's see, the force is negative 106.4 newtons. I got that from here. Divided by, let's see, where's the mass of my ball? Right there, 0.14 kilograms. So I get an acceleration of negative 760 meters per second squared. All the negative sign means is it's to the left. And there's my acceleration. Alright, now, suppose I have the brakes on a car exerting a force. Whoops. Let's go back. All the way back. Exerting a force, that's what happens when you have too many windows open. Exerting a force of 640 newtons. There's F. It was moving at an initial velocity of 20 meters per second and comes to a stop. Now you know that means V final is 0. And the car weighs 15,680 newtons. What's the car's mass? This is not a trick question. Again, remember, everything I've taught you before, you have to use now. And we're going to go to the formula Fg is mg. So, to find the mass, we need to divide both sides through by g. Goodness, this is acting up. So the mass is equal to its weight divided by gravity. Now, remember, 640 newtons tells me this is, 15,680 is its weight. So, 15,680 newtons divided by 9.8 gives me a mass of 1,600 kilograms. As with the last unit, we always need to be finding the mass. What's a car's original momentum? All right, the original momentum, P equals mv. So I'm going to call this PI for initial. It's mvi, or v naught. Let's see, the mass is 1,600 kilograms. The initial velocity is 20 meters per second. So I have an initial momentum of 32,000 kilograms meters per second. Trouble with my pen. Now what's the change in momentum? The change in momentum is equal to mass times v final minus v initial. Now, let's see. This is going to be the mass, which is 1,600 kilograms, times the final velocity is 0, minus the initial velocity, which is 20, or negative 32,000 kilograms meters per second. Now, how much time did it take to bring the car to a stop? This seems like a trick question, but it's really not. I want to use the impulse momentum theory. Ft equals change in momentum. So I want to know how much time. The time is just going to be the change in momentum from part C divided by the force applied. So this is going to be 32,000 kilograms meters per second divided by the force of 640 newtons, or 50 seconds.